Hi, this is Dr. Xu teaching design of experiments for engineering research. In this video, we will talk about the one-sided hypothesis testing. In the previous video, the alternative hypothesis is the population means are different. We don't care if one population mean is larger or smaller than the other mean. Sometimes we want to test if the population mean is larger or smaller than the tested value, so we can set up the alternative hypothesis as mu test large than mu compare or mu test smaller than mu compare. Using the same data set here, the sample average is 16.764. Now we want to compare whether the tested material population mean strength is smaller than another material with a mean strength of 17.04. We will use the p-value in this hypothesis testing. There are 5 steps. The first step is to state the null and alternative hypothesis. The second step is to choose the level of significance, most of the time 0.05. Then we will calculate the t-value and find the p-value corresponding to the t-value and compare it with the significance level. And lastly, we will draw the conclusion. If p is less than or equals to the significance level, we will reject the null hypothesis, and there is sufficient evidence that the average is larger or smaller than the null value. If the p-value is larger than the significance level, we will accept the null hypothesis, and there is insufficient evidence that the average is larger or smaller than the null value. In the first step, we state the null hypothesis as mu test equals to mu compare, then that equals to 17.04. And the alternative hypothesis HA is mu test is less than 17.04. In this hypothesis testing, we will find if we have enough evidence to reject the null hypothesis. If we cannot find significant evidence rejecting the null hypothesis, then the two material strengths are the same. Otherwise, we have significant evidence supporting that the tested material mean strength is less than that of the compared material, which is 17.04. The second step, we determine the significance level. Here we use the most common significance level of 0.05. So alpha equals to 0.05. Now, because we only want to know if the tested mean smaller than the known mean, so we only look at the one side of the tail. In this case, we look at the left side of the tail. And the significance level 0.05 is represented as the purple area here. If the calculated p-value is larger than 0.05, we fail to reject the null hypothesis. Otherwise, if the p-value is smaller than 0.05, we reject the null hypothesis. For example, if the t-value is here, then the calculated p-value can be represented by the area here. This p is less than 0.05. If the null hypothesis is true, we only have less than 5% of a probability of getting a sample average that is this small in this area. We have determined that this probability is so low and conclude that it is unlikely for the two means are equal, and support that mu test is less than mu compare. The next step is to calculate the t-value. We will need the calculated sample average and sample standard deviation we have done before here. So t equals to y bar, that's 16.764, minus 17.04, divided by sample average standard deviation, sigma y bar. It can be calculated using the population standard deviation sigma divided by square root of sample size. We don't know the population standard deviation, and we can use the sample standard deviation S as an estimate of the sigma. So sigma y bar equals to this S divided by square root of 10, that is 0.316 divided by square root of 10, equals to negative 2.663. Now we find the p-value using the function in Excel. We use the tdist function, so equals to tdist, and the first parameter is the positive t-value. Here is 2.663. The second parameter is the degree of freedom. In our example, is 10 minus 1, that's 9. And the last parameter is the tail. Now we use the one-tail distribution because we only care about whether mu test is less than mu compare, and we don't care about if mu test is larger than mu compare. So I put 1 here. So P is 0.012959. P equals to 0.01296. This means the t-value corresponding to the sample average of 16.764 is approximately here. So t equals to negative 2.663. And this area here is smaller than 0.05. This means if the testing material strength true mean is here, 17.04, we would have a very low probability, about 1.3%, to have a sample average of 16.764. This probability is so low, so it is unlikely the tested material strength true mean equals to 17.04. Lastly, we draw the conclusion because the p-value equals to 0.01296, which is less than the significance level of 0.05, we reject the null hypothesis and conclude that there is sufficient evidence that the tested material mean strength is smaller than 17.04. In practice, if you want a material that has a strength of 17.04, you probably don't want to pick this tested material. Okay, this is Dr. Xu. Thank you very much for watching. I will see you in the next video.